So we've covered some general information about sequences, but there are two particular types that I'd like to cover. We'll do this in two lectures. The first of these is arithmetic sequences. Arithmetic sequences are sequences whose consecutive terms have a constant difference, and we refer to that difference as d. In the example here, we have a sequence that starts with 7, followed by 10, 13, 16, and 19. As you can see here, the difference, or d, of this sequence would be 3, and we're mainly focused on the difference. Take this sequence for example. We have 1, negative 2, negative 5, negative 8, and negative 11. Now this is going in the negative direction, but you can see that the difference between the terms is constant, so the d for this sequence would be negative 3. On an exam or quiz, there are a couple of different questions you're likely to get for this topic. One thing you may be asked to do is, when given a sequence of numbers, define d. Or you may be asked to identify what type of sequence it is. And if d is a constant number, you'll know it's an arithmetic sequence. Another type of question you may get will be to find the formula for the nth term of an arithmetic sequence when you're given the difference in some term, usually the first term. Let's see an example here. Here they've given us a difference, 5, in the first term, which is 4. Since we know this is the first term, we know that n is equal to 1. And they've already told us that a sub 1, or the first term, is 4, and they've given us the difference. So what do we have left here? Well, we have a constant. But since we have all the other values here, we can solve for c. Let's first rearrange this equation as shown here by subtracting dn from both sides of the formula. That gives us c is equal to, in our case, a1 minus d times n. Knowing that a sub 1 is 4, and that d is 5, and that we're dealing with the first term, which makes n 1, and that's it, that's all we have to do. Let's see a couple of examples here. We're asked to find the formula for the nth term of an arithmetic sequence, whose common difference is 5 and whose second term is 20. Notice here that they're giving us the second term of the sequence, so that would make n equal to 2. They've also given us a common difference of 5 and the value of the second term. So just as we did before, we can solve for c here, come up with a formula, then we can plug in any value we want for n and find out what that term is in the sequence. So using our formula here and filling in the values gives us a second term, which is 20, and that's equal to the common difference times the term in question, in this case the second term, plus c. Solving for c again, we get that c is equal to negative 10, and now we have the formula. A sub n is equal to 5 times n minus 10. This problem demonstrates one of the variations that we talked about before. Here they want you to find the nth term of an arithmetic sequence whose first two terms are 7 and 12. Since this is an arithmetic sequence, we know the value of d is constant, and so when given the first two terms, we can easily see that the difference between those is 5, so we know that d is 5 in this case. Let's use the difference we now know is 5 and the two different values and calculate and see if we get the same constant. For the first term, we have 7 is equal to 5 times 1 plus c. If we subtract 5 times 1 from both sides, we get c is equal to 7 minus 5, or 2. Let's check the other point to see if it agrees with what we have above. This isn't entirely necessary, but it's never a bad idea to perform these extra steps if it helps you check your work and prevent mistakes. So for the second term, we have a value of 12, and that's equal to 5 times n. In this case, it's 2 since we're dealing with the second term. Rearranging this equation by subtracting 5 times 2 from both sides, we get c is equal to 12 minus 10, and that is also equal to 2. So now that we know what the constant is and the value of d, we can come up with a formula for this sequence, and that is a sub n is equal to 5n plus 2. But the question asks us to find the fifth term in this sequence. And now that we know the formula, we can do that by plugging in 5 times the term in question, which is 5 in this case, plus 2, which gives us 27. Let's do one more of these really quickly for reinforcement. We have the formula for an arithmetic sequence, and we have 2 points, 2 and 9. We can see from this that d is 7. We can pick one of the two terms above to solve for the constant. Here we plug in the first term. So a sub 1 is equal to 2. We know d is 7, and n is 1 since it's the first term. Subtracting 7 times 1, or 7, from both sides of this equation, we get c is equal to 2 minus 7, or negative 5. So now having the constant and the difference, we can write the formula as a sub n is equal to 7n minus 5. And to find the fifth term of this sequence, you just plug 5 into the equation for n and solve. In this case, 5 times 7 is 35 minus 5 is equal to 30. Let's break here. When we come back, we'll talk about geometric sequences.